So with the VI running at steady state, you're going to turn on the voltage supply. Note that you'll have already set it to a value and had the cart in steady state prior to actually turning on the motor. What you can see is that the transient is observed on the screen, and we'll go over the other part as it goes to steady state. You would observe this normally throughout the lab. So to determine the frequency that you're oscillating it at, you'll use the digital tachometer. You'll push the test button, aiming the laser at the white piece of tape, trying to keep your hand as steady as possible so that it doesn't fluctuate too much. You can observe in this case that it's at approximately 58.2 RPM. Now, we can observe that the transient is dying out and it's deviating more towards steady state. We'll observe it a little bit longer just to make sure that it's all pretty much there. Note that in some of these cases the amplitude of oscillation will be low enough where there will be some fluctuation and you won't get that perfect steady state constant amplitude. You'll have to approximate slightly. So these are more for the low amplitude cases rather than higher ones. I would say it's nearly there. In lab you'll want to actually wait a little bit longer, but just for the purposes of the demo. What you can observe is that if this were closer to steady state, you would just take the average amplitude of the waveform compared on the screen. You can export your data as well, and you will have to for analysis purposes, just as the same way as in the displacement trials. But from that amplitude, you can get the gain of the system as compared to your input amplitude.